video is on quantum numbers. So quantum numbers is kind of like a positioning roadmap to where the last electron was that entered an atom. So quantum numbers have to do with every atom's last electron can be described by 4 different quantum numbers. And our quantum numbers are first n, the principal quantum number. This denotes the electron's principal energy level. It has integer values of 1, 2, 3, and so on. And this describes the orbital's size, energy, and distance from the nucleus. So this is like what Bohr talked about with their energy levels. Then we have the angular momentum number, or letter L. It's a lowercase cursive l. This describes the orbital's shape, so whether the orbital is an s, p, d, or f orbital. This has integer values from 0 to n equals 1. So given my n number and given my orbital, I can figure out what my L value is. So for example, S is my first energy level with an n equal to 1. That means that my L value, my azimuthal quantum number or angular momentum number, is going to be 0. P is my second energy level, so my L value will be 1. D is my third energy level, so my L value will be 2. F, 3, G, 4, and so on. Then we have our magnetic quantum number, which is m sub L, and this denotes the orbital's orientation in space. It has integer values of negative L through L. So we must first know our L value, or our angular momentum number. For S, again, this is 0, 1, 2, and 3. That means that our m sub L, or m value, is negative L to L. So for my S, it's just 0. For P, it's negative L, which is negative 1. And then integer values from there is 0 and then 1. For my D orbital, it's 2. So we go from negative 2, negative 1, 0, 1, 2. And for F, it's my integers of negative 3, negative 2, negative 1, 0, 1, 2, and 3. So this tells me about my number of orbitals that I have in my different energy levels. You'll remember back when we learned about energy levels and electron configurations that we said things like the s orbital has 2 spaces for electrons because this was our s block, and there were 2 elements here, so we had one orbital line with an electron here, an electron here. That in our p orbital, we said it was 6 wide, and electrons like to be paired, so we have 1, 2, 3 orbitals here. We went up and down with our electrons, right? So we went up, 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 and then back down, down, down when we drew those. And so that was a nice way to describe it with the way that the periodic table is laid out, but the actual reality of where those orbitals come from has to do with the quantum numbers. So here for our s orbital, we have just one spot for our orbital. It's at spot 0, so it's that one energy level, or I'm sorry, at that one orbital. For my p, I have 3 spots, so 3 orbitals. I have the negative 1, the 0, and the positive 1. For d, I have 5, a negative 2, negative 1, 0, 1, and 2. And then for my f, my negative 3, negative 2, negative 1, 0, 1, 2, 3. And so we would have gone in, and you don't need to write this, but we would have gone in and said, you know, if I had a p orbital and I had 4 electrons, I'd have a spot here, 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 and then the next one would come down. Okay, so that's kind of where those come from. So in total, my number of orbitals that I have in my s orbital, I have 1. In p, I have 3. In d, I have 5. And in f, I have 7. It's my number of orbitals, which means my number of total electrons I can hold is 2, 6, 10, and 14. Thinking back to, we talked about when we filled our orbitals, we always filled with them pointing up first and then down. And we mentioned briefly that it has to do with the spin, but we'll get into that if you take AP. Well, here you are. So that's because we have this electron quantum spin number. And so M sub S, or S, this describes the electron's spin. It either has a value of positive 1/2 or negative 1/2. If it's spin up, it's positive 1/2. Spin down, it's negative 1/2. And we can see the first electron always enters spin up, which is why we went up first. So 1/2 or negative 1/2, 1/2 being first. And this can be summarized, quantum numbers can be summarized in Pauli's exclusion principle. And he said, well, an orbital can hold at most 2 electrons, one being spin up, or positive 1/2, one being spin down, which is negative 1/2. The reason that they have the charges and values the way they do is because opposite spins will produce opposite and attracting magnetic fields. So this is so our atom doesn't spin out of control, right? If one electron is spinning this way, the other one's going to need to spin this way, so that way both of them aren't spinning the same direction and they spin out of control. They're counteracting each other. So Pauli's exclusion principle said, well, no 2 electrons can have the same 4 quantum numbers because they're in different orbitals with different spin at different parts of the orbital, right? So there's different lobes, which we can look at. There's a picture in your textbook and we'll look at in class. And then we had different energy levels. So let's go through a couple examples. So if I have the element Se, I need to first figure out where is that element's location on the periodic table. So selenium is here. And if I look, I have my energy levels drawn in. It's an energy level 4. And it's 4, this is my P block, so 4P, 1, 2, 3, 4. So the last ending spot of this location is in spot 4P4. Remember, this is the S, the P, the D, and then the F block. So energy level 4, P4. So I'm going to make a note that this is 4P4. So my N is my principal quantum number. It's my energy level. I'm at energy level 4. My L has to do with my orbital and the orbital shape. So because I have a P orbital, that means that my P has an L number of 1. So I get 1 here. Then my M, this one's a little tricky. So my M value, I have to go, I'm in my P block, my P orbital. I have options of -1, 0, or 1. I have 4 electrons, so I'm going to fill up, 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 and then back down. So this guy is in this -1 spot for my M sub L value. So that means this is -1. And then, because it filled in the down position, that means that it has a -1/2 as my spin. So let's go through vanadium. Vanadium on our periodic table is here. Again, my 4th energy level. But I'm in my D block, so remember this is 3, 4, 5, 6. So I'm in 3, D, 1, 2, 3. So the end of my vanadium is 3, D, 3. So my N value, my principal quantum number, is 3. My L, my angular momentum, the shape that I have, is my D orbital, and D is 2. Then my M has to do with where my electron is in my orbital. So it's the 3rd electron to fill. So that means for my D, it's going 1, 2, 3. So it's in the 0 spot. And then, because it's the first one in the 0 spot, it's going to be spin up. So it's +1, half. Next, I have potassium. Potassium's here. It's in 4s, and it's my first one, so 4s1. My N is my principal quantum number, my energy level, which is 4. My L is my angular momentum, or the shape of my orbital. So I have an S, so that makes this 0. My M sub L is my orbital's orientation, and that has to do which orbital it went in. So my S, that one's easy. There's just one spot, and it's in the 0 spot. So 0 again. And then it's my first electron, and so that means it must go spin up, which is positive 1/2.